I think I've got this down. I think my computer screen is tilted the right way. Good afternoon, everybody. We're going to talk about my demonstrative lesson that I like to give. It's one of my favorites of all time to give. It doesn't seem like it's very difficult, and it's not supposed to be, but they get a maximized amount of learning from this lesson as far as design and understanding measurements and understanding why it's important to do the different things that we do. It's important to measure things in a certain way. So I like to lead off this topic with an EQ that says, why is it important to measure things with detail, right? And I give the students a chance to tell me what they think the reason for measuring with detail is. Also, it gives the students a chance to tell me how much detail they see when they look at something, right? It's very important to understand their perspective. I like to see everybody's perspective and how they handle things. This is unit 4.1, and it's technically, or it's unit 4.0, and it's technically lesson 4.01 for the design process. It's understanding design elements and design purposes. So we have to understand how to start, which is understanding how to represent our world. This lesson actually started in older curriculum, and we have taken it and used it and taken it apart and reconstructed it to be used as part of the new curriculum as a supplement to be able to do, add enrichment to some of the stuff that we got that's in the new stuff. The new stuff is very broad, and I like to bring it back to actual application and learning. So the understanding of measuring and the understanding of why detail is important. It's very important that we have detail. And the title for this lesson is 3 Ways to Represent Our World, right? What are the 3 ways with which we represent our world? All right, so it's going to require our students to get up. I break them up into 4 groups. So my students, I usually tell everybody, we're going to get you in 4 groups. When they come in, I have a hat of some sort that already has note cards in it. It has a list of 4. It'll be group 1, group 2, group 3, group 4. If there's more than that, we have a 5th group, right? So we have a hat. They draw a card out. It'll say which group they're in. It will assign them a role, right? So we have 4 different roles, or 3 different roles, if however you want to look at it. One is the group leader. It's the person that keeps them doing their lesson. One of them is the person who records what they're going to put down, and I'm going to show you that stuff here in a second. And then the other 2 are doing the work as far as measuring and doing some of the technical work. But they're all going to work together, and that doesn't mean that other people can't measure and things like that, but they all get to do something. And then in other lessons later, the roles will reverse. So they will do the same thing. They'll draw a name out of a hat, and their roles will change, and we get to see how people handle different roles. The responsibility. The cool part is when you have a responsibility, you can't let one person do all the work. You have to do it with them. So it's very important that everybody has a responsibility. They don't get to just shy away and let 2 people do all the work. They're responsible for that stuff. So when I come to a group, I can say who's responsible for measuring, and I can put that responsibility, right, that kind of accountability on that person, right? So it's group work, they're collaborating, so collaboration's big, and it's a job where they all have to have a part and a role. All right, so there's 3 ways. I'm going to show you here in a second. I think you maybe see me on the screen. I think we're sharing the screen. There's 3 ways to represent our world. So this is kind of the day before we set this up with a PowerPoint that says, how do you represent your world? And it's from the old ITEA curriculum that is not really old. It's just somebody else's name on it, but the ITEA curriculum. So the ways with which we represent our world. So we always give kind of our mission for what engineering and design is, right? We're trying to provide a systematic, iterative problem-solving method. We can repeat it, we can say it, we can do it, we can constantly repeat it, which produces solutions to human needs, wants, and desires, right? We're solving a problem. Problems are not just bad things. Problems are what I need solved. What is my requirement, right? So that's how we always start a lesson. We move from that to, at various intervals of the engineering design process, conceptual, physical, and mathematical models evaluate design solutions. So we're making models. The two key words that we're going to add into this lesson are prototype and model. A model is something that you look at conceptually, and a prototype is something that we work with and we can test. I'm not going to show you all of these slides because it's lengthier slideshow, but this is kind of the meat and potatoes. What we talked about yesterday, or what we talked about in this PowerPoint, is that there's three types of modeling, right? Three types of representing our world. You've got written and spoken. I can tell you about it. So how, and it starts with, how do you tell me about that door, right? How do you tell me about that door? What is your detail you can tell me about that door? So students get to, they get to use the door as one of their examples in here. How can you say what exists with a door, right? Mathematical is giving me numbers, giving me a frame of reference or scale, and then graphical is being able to take what you just told me and the shapes that you just told me and all of the things that you just reported to me and measured and putting it on paper. So now I have a clear and concise description of what you want. But the key is I don't give them anything more than that. So I want them to be able to experience doing this stuff and then failing. I want them to fail. This lab is about them failing. And if they don't, even better for me and better for them. But this lab is about them giving me their description of something. And then I can show them what an engineering description looks like and how it relates to systems, right? So how it relates to systems. So that's kind of the lead into what we do. That's how I talk to all my students. The way I communicate with you, we're in a very business-like way. So I'm going to pick this computer up for 2 seconds, and I'm going to show you kind of the tools of the trade. I don't really have a way to do it other than that. Let me see if I stop share. You should be back to me on the screen. Perfect. What are the tools that we're going to use? So I'm going to pick this up because I don't really have a better way. I could have typed it in, but put a picture in, but this is it. So we're going to use, they all come in the door. They pick up 4 and taking all of our keys, so I don't have my tape measures, but my tape measures, we have, love these, right? We have all kinds of different things. So you got your calipers, your tape measure, your yardstick, and a actual pulling tape measure for measuring larger things. So what are they going to do? What are they going to do? I give them 4 objects that they're going to measure. Right? So I give them 4 indescript objects that they're going to measure. They're going to measure a book, right? We start simple. We go from simple and we work to hardest. They're going to measure a book. Give me a description and a measurement of the old technology books. One of my favorite things, right? Give me a description and measurement of this, right? Very simple, very easy. We start them off easy, right? Then we move from the book to the door, right? The door, it doesn't look very complicated, but believe it or not, by the end of this lesson, we learned that it's very, very complicated, that door, right? That ends up being the focus of what we talk about. We move from the door, you can walk with me. We move from the door to this microwave. They have to give me specific measurements and detail on the microwave. And the very last one is they're going to use one of our computer monitors in class and give me a description and a detail of a computer monitor in class. So they've got 4 objects to measure. They've got 4 objects to draw, right? We learned the day before the 4 different types of drawings. They're going to use isometric as a drawing, which is drawing things at a 30% angle and showing depth, length, width, height, and all those things. They learned some of that stuff, so they're going to apply that to what they're getting ready to draw. And then they're going to have about 40 minutes. It's an hour and a half long class. They're going to have about 40 to 50 minutes to get together and do all of these tasks. So while they're doing these tasks, I'm going to walk around and facilitate. I don't ever want to give them answers because I need them to understand why what they did is right, wrong, or indifferent, but I'm going to help them and make them understand how to get detailed measurements and how to correctly represent what they're doing. The reason it's important, we're going to tie this into their work world, is because if I give a complete answer to a question, right, especially if it's in engineering, if I give a complete answer to a question somebody has asked me, then they don't have to ask me again. And if they don't have to ask me for more information, it's less time, and less time saves money, and money keeps your job and makes you valuable, right? When people don't have to ask you twice, it makes you a valuable employee if you can give them a complete whole answer, right? And especially when it comes to design and all these things, it saves time. And oh, by the way, identification of systems helps us be able to break down what each thing has. So the example that we use the most. So what will happen is they'll do their stuff. And then what I give the students a chance to do is report back to me what they observed. So I come up to the board and I usually draw for them, since they did the drawings on the paper. I'll say, okay, so let's hear about the book. And I pick a group and I say, tell me about your book. What did you measure? What did you come up with? And I say, what was your description? And they tell me, well, it was a purple book, right? Whatever they came up with. Well, it was this, however detailed they went. It's a purple book. Okay, well, give me the dimensions, and they'll tell me what the dimensions are, and I'll physically draw the book on the board. So, okay, you measured the book. It's 11.5 inches tall. I'll draw an 11.5-inch book, right? And then I'll add 11.5. Right, and then they'll say it's 8.5 inches wide, so I'll do 8.5, right, and I'll do 8.5, and then we'll measure them together, keep them together, and then they'll tell me it's 1 3/4 inches thick, and then they'll tell me it's 1 3/4 inches thick, so we draw the book, right? So now, how do I design off the book? Does it match? Without me having ever seen this, if I was a person on the other end of the phone and you didn't have a camera and you couldn't show it to me, does it match the description of what you just did? Yes, right? So you've done the book. Congratulations. What are the elements of the book? Well, it's got a cover. Usually these are the things they leave out. What are the elements? How do you break down the systems? And they leave out, well, it's got a cover. Is the cover made of something, right? It's one of our 9 core technologies. It's made out of cardboard. It's a material. It has these different features. It has pages. They forget to give me descriptions on pages. So we go over the book. Book's pretty simple. Most of them get about 85% of the book right, or there is no such thing as wrong, but they get 85% of what I'm looking for on the book. Then we move to the door, and the door really, so the rest of it, I don't necessarily have to have the rest of it. I like the rest of it because it adds other things for them to be challenged for drawing, but the door is where the crux of everything we do is based off of. So I do the door in the middle, because the door can bridge me to the more complicated things like the monitor and the microwave, and I can reference certain things. So you have to tell me about the door. So students usually tell me about the door. It's a door. It's a rectangle. Okay, it's got a window. Great. All right. And then they just kind of stop. This has been done. We've done this now 4, 5, 6 times, and they kind of stop. They think that that's the only detail that needs to be done on the door. And then they measure, it's a rectangle, it's 1 3/4 inches wide, it's 7 feet tall, it's 3.5 feet wide, it's got a window. They may even give me measurements on a window, right? So then we go over the door and I say, well, how did you break the door down? It's very important to break down the systems of the door. And they say, well, what do you mean? And I say, well, it's got systems. The door has systems that are in all part of this door. What are the different systems, right? So obviously it's a structural system. And obviously it's got a window. We talked about the window. The window has a frame. So now when we're doing the door and we're describing the door, we need to write down the individual systems so we don't miss any parts. So you can write down wood door, right? Here's the dimensions for the wood door. Window, here's what's on the window. It's got a metal frame, it's got glass. The glass has some sort of structural property so it doesn't break when students try to hit it or whatever. We have a handle. The handle it's a system, it's a subsystem of the door, it's a system with inside this system. It has subsystems inside this. It's got screws that hold the plate on, it's got the actual latch, it's got the handle, it's got the lock, right? So the subsystems of the actual handle assembly, they have to list those things. Usually something that's been overlooked, right? Also, the door, another system of a door is the hinges, right? The hinges, there's 3 of them. Each hinge, so sometimes I have students list the hinges, that's fantastic. Each hinge has 8 screws. They never list the screws. How do we think deeper into what these screws are? Are all screws the same? Do they have different measurements, right? Could a student have taken a screwdriver provided and unscrewed a screw to see what kind of screw, how long it is? Is it a metal screw? Is it a wood screw? Things that we learn later, right? The different types of screws. What's the head configuration of the screw, right? What is the material all these things are made out of? There's 17,000 different types of door handles you can buy, 17,000 different types of hinges. Is it an indoor hinge? Is it an outdoor hinge? Does it have a brushed metal finish? Does it not? Is it a brass hinge, right? What's the rating on the hinge, right? They all have things. What about the kick plate? Everybody forgets the kick plate. Door's got a kick plate. It's got 12 screws that go in it. They're different type of screws. The hinges have recessed screws. The kick plate has dome screws, right? It's a different type of screw. What's the detail you're willing to go to describe something? It's very important, right? So some people see a door. I see 5 or 6 different systems that students have to operate. So that's what I like to relate to them about all the different systems. Now, they have different ways to convey these things. I love the calipers. We just added the calipers a couple years ago. The calipers give a student a different way to measure, and they have to be very careful because it's also got a different type of measuring system. This is a metric system compared to inches and feet. So they have to be very careful, or they have to be able to convert inches and feet. Again, we're in Tech 2. They have to be able to take these things to the second level, right? So then they move on to the microwave, and they have to show relation of objects within the microwave to each other, kind of the same as this window. This window is great knowing the dimensions, but did you give me a point of reference to be able to place this window on this door when I'm designing around it, right? So a measurement from here, a measurement from there, right? The microwave's got all kinds of cords and cables. How thick are the cords and cables? Which tool would be the appropriate tool to use? These are my tasks when I go around facilitating and they don't know how to measure a cable. Hey, look, you've got a set of calipers. Go use the calipers to measure a cable, right? That's a great way to measure something that's round, that's a cylindrical thing. So again, they get to measure all these different things. And then they get to report to me, and they're all different level of complexity. And then they get to report back to me, and they give me their assessment, right? And then they compile it as a group. Now, each group worksheet has the group members that can list who the group members are and how they provide. But it's really up to me to walk around and make sure that everybody's on task or paying attention and understanding what's going on. I'm the facilitator in the classroom. I don't want to be the person that's teaching them this stuff. I need them to screw up on this door. I need them to screw up on the microwave, right? And it's not really a screw up. They're doing things that they've never done before, but I need them to make that mistake so they understand that you're thinking on surface level, you're not digging deeper. If you want to be a designer, if you want to be an engineer, if you want to be a video game designer, you have to think beyond the surface. It's very important. So again, we wrap this up usually with they turn their, sorry if I got off screen, they turn their assignments in, right? And I give them a nominal grade. I don't really necessarily believe that grading matters in this particular experience. I believe that the experience of doing it and understanding why we do certain things is what matters. So understanding how this works is really more important than the grade. This, the students will never understand, is really just the work that you provided, and you're showing me that you're understanding what I'm talking about. It's not necessarily a grade, right? So you're getting a participation grade in my labs more than you're getting a grade. But that's how we do my labs. And a lot of my labs are the same way. I like to be interactive, and I like students to make their own assumptions, and I like to have students understand what they do. Not a lot of different things that you need for this lab. It's very simple. You don't have to pick a door. The door is the easy one for me because it's very rigid and structured, and has a lot of things that are exactly the way they need to be, and it has a lot of things to understand that are easy to understand. But you can pick anything. You can pick a chair. You can pick all kinds of different things. The key is that they understand how to think at a level beyond just what they see in front of them, how to get to something and identify all the systems involved. And if, listen, that door is really easy. If I understand what the systems are, I don't miss anything, right? I don't miss anything that's on the door because I know I got to do everything about the latch, so I got to focus on the latch. I know I got to do everything about the window, I focus on the window. I know I got to do everything about the kick plate, so I focus on all the parts of the kick plate. And I know I got to do all the hinges. And I don't miss anything. There's nothing else to miss, right? So getting them to drill into that deeper understanding of what that door is really helps them understand how to do pretty much all the other things. So once they get past the door, right? Once I've facilitated them and nudged them in the right direction past the door, the screen monitor, the computer monitor, and the microwave, they go like this, right? Super easy. Now, there is a variation I want to make sure I point out, and it depends on the class I get because not all the classes I get in the same way, right? There is a variation of this lab for a higher level. Sometimes I don't get students that are masters of technology, right? That may not have even done this lab before I got here. Sometimes this is my 2.5, this is my 3rd year-ish, right? So some students took this 4 years ago and they haven't done this. We also have a lab where we can take graph paper into the cafeteria and do whole-scale measuring of the entire room and place objects inside a room and understand how numbers and details work, and I allow them to do a little bit of drafting and drawing things up, and we get to use it. The first year we got to turn it into the cafeteria so they could place the cafeteria back the way it was. It was kind of a thing that gave them a useful thing. That picture's still on the wall in the cafeteria. That's a usable thing, so students were very happy about that. We have other things that we can branch this into at a higher level. Again, this is kind of the first level, depending on the students that I have. We can branch this into a higher level as far as measuring fields, sports fields, placing all the different objects on sports fields, even the basketball court, how to measure a basketball court, how to place the gym on a piece of paper in a reference in a frame. So there's other ways to do this. Look, even if we were to go inside of a barn, a shed that we have here, and placing studs on a reference scale and drawing the different types of drawings, giving cross sections of a shed. There's all kinds of different ways you can branch this lab out and show detail, right? It's all about detail and representing a product and being able to describe and analyze a product to show somebody. So this lab kit has any number of possibilities. We use it here, we love it. It's a fun lab. It doesn't mean that it's perfect for everybody, but to me, it really gives the students the ability to understand and branch what they just learned into something else. And then I get to reference back. I use that door as a reference for the rest of the year, right? You're not thinking deep enough. You're just thinking door, right? I use that all the time. You're thinking door, you're not thinking systems, right? You're just thinking wood, right? I always tell my students, we're not cave people, right? We don't speak in one-word sentences. Wood, bird, tree. We don't do that, right? We think beyond that. We think of systems in the entire process rather than just door, right? So thank you for listening. I'm wordy, I know I am, and I don't really apologize for it. I'm an engineer, I love doing what I do, and my students kind of get this crazy person every day. So if you have any questions, feel free to comment on the comments below when I post this. I would love to share this lab if anybody needs it. Thank you for taking part and listening to me for the past 20, 30 minutes. Have a great day. Again, thank you for doing what you do, and thank you for being on here. Thank you. Have a good one.